So good afternoon everyone and welcome to Big Data London. We are here at the Bright Talks arena and we're here to talk about building a successful big data strategy. Got a number of panel members with me today and I'd just like to do a quick intro to everybody, so I'll start with you, Martin.
Good afternoon. My name's Martin James. I'm the Vice President for Percona in EMEA, and Percona's mission in life is to enable organizations to successfully deploy and operate open source databases.
Cool, thank you.
Hi, I'm Patrick Callaghan. I'm an enterprise architect for DataStax. DataStax is the company behind the open source project Apache Cassandra, which is a massless distributed database used by some of the biggest companies in the world.
Cool.
Hi, I'm Gary Richardson. I'm from 6.6, where I'm the managing director of our data practice. 6.6 is particularly focused on secure transformation. So that is, how do we take our clients from where they are today securely into things like the cloud? How do we enable them to embrace data ops, DevOps, and how do we do it securely so that they can derive more value from their data?
Finally, Louis.
Hi everyone, my name's Louis Polycarpou. I'm Technical Director for Data Engineering and iPaaS Technologies at Informatica. Informatica is the leader in enterprise cloud data management software, helping customers with their data integration, data governance, and hybrid integration requirements.
Great, thank you. And finally, I'm Andy Crossley. I'm from Oakland. We're a data consultancy focusing on data strategy, data governance, and transition to the cloud to move you to analytics. So we're here to talk about building a successful big data strategy. And before we sort of dive into the detail, I'd love it if you guys could take a small trip into memory lane and actually talk a bit about big data. Seems to have been around for a long time already. So where has big data come from, and what have you seen in your experiences successful data strategies, big data strategies in the past? Some examples maybe of what people have got right, but probably more interestingly what people have got wrong. So Martin, I'll start with you.
Certainly. I think if you look back at the early days of big data, it was about Hadoop, it was about being able to store large amounts of data on commodity hardware to provide cost savings. And when I fast forward to where we are now, are those objectives still the same ones? We've seen the transition to the cloud. That's probably the commodity hardware part of the discussion. But there has been a change in what is the technology expectation from that Hadoop to really a multi-DB big data strategy. That's what I'm seeing in my customers at the moment. Okay. That it isn't a single solution, it's many solutions that go towards it.
And Patrick, have you seen anything in terms of where organizations have come from that typically organizations got wrong?
Yeah, I think to Martin's point, a lot of the idea behind the start of big data was the big Hadoops, the dot-com, the bubbles and the booms, where people were just creating huge amounts of data. The problem was a lot of that data wasn't useful. It became, we were talking earlier on about a data swamp rather than a data lake. And I think now people are more focused on being proactive in cleaning that data, making that data actually worthwhile in holding and storing. And then being proactive in using that data, instead of being reactive, like using it tomorrow or next week or the next month, using it today in the moment, in kind of real-time streaming analytics, that kind of focus. So I think that's more where we are now, is we're moving to a real-time, proactive approach to data and analyzing that data too.
So when I reflect back of why a lot of big data strategies have failed, it's the failure is not the technology. I think most technology is an engineering challenge that we could overcome. What we forgot to do was train the big data workforce. We didn't focus enough on the fact that the lingua franca of data is SQL. So we spent an inordinate amount of time trying to re-engineer and think about how do we move to things like MapReduce, and then we started thinking about how do we implement things in Scala, and we were so preoccupied with the sort of technical challenge of programming in this new paradigm that we forgot that the workforce was SQL orientated. And so as a result of that is we left a lot of people behind. And so the technology eventually caught up and realized that the only way in which you're going to make these things pay and drive business value is if you can have a common language. And the common language still is SQL. So you've seen a lot of the vendors play catch up in trying to put a SQL interface because they knew the only way in which they can drive revenue, which is ultimately what a technology provider is looking to do, is drive revenue, return on investment to investors, and have happy customers, was how do we get the huge amount of SQL workforce productive on these new platforms? And I think we're there now.
So do you think, Lou, onto you, that sort of trend, those technological barriers drove a certain behavior back then that we saw in terms of some of the limitations to successful big data strategies in the past?
Yeah, I mean, I think if you look over the last 5 years, there's been like unparalleled change that we've seen across the whole technology stack. That's everything from storage to compute to the database options, AI and machine learning becoming a thing, more widely adopted. That's cut across pretty much every layer, and now with cloud and other disruptors, there's more and more technology options available to customers. So I think a lot of the initial projects, what we've seen at Informatica, were more skunkworks projects, people trying out the technology on a departmental basis, on an offloading perspective, trying to move data from their data warehouse into data lake and seeing what value they could get out of it, but almost fighting the technology. I know you said that some of the technology wasn't a barrier, but trying to learn things and find the right way to do things.
It was that learning curve, is all of a sudden, when you look at your average data engineer, or as we used to call them, sort of an ETL developer, they were used to being very much in a GUI, tool-driven environment. Now all of a sudden, when you're working on Hadoop, all of a sudden you've got to learn Java, and you've got to understand real hardcore software development lifecycle, which was a learning curve which you had to overcome. So you couldn't take a guy who's had 10 years experience in SQL Server and chuck him at a Hadoop cluster running on Linux. It was, there was a lot of obstacles to overcome.
Yeah. But also there wasn't really a chance for stability in the early days because things were innovating so rapidly, APIs were changing, new farm animals in the Hadoop landscape coming out on a weekly basis. So everyone was trying to learn and trying to evolve without really delivering the real business value of what the whole big data initiative.
Because there's a clue in the name. When you have an implementation called Zookeeper, you know that there's something that has to be managed.
Yes.
Yeah.
And so I guess in terms of other learnings, so we've talked a bit about the skills base that's needed. We've talked a little bit about the technology. What else have we learned and we're starting to get right that then brought us up to today? Patrick, you started to touch on a bit of that before.
Yeah, I think where we're seeing things really work now is the AI and machine learning in the back end. So building these models, building whether it's recommendations, whether it's suggestions, categorization, and putting that then to the forefront of your applications and your systems. So when things are happening in real time, you can take advantage of those models. You can actually start plugging in. So the typical thing is things like fraud. You should, in a way, be able to say a transaction is coming in from a credit card or something like that. Look at the context that credit card is in, that transaction is in, maybe against other credit card transactions from that vendor or the merchant or the user itself, and put it in context and then make decisions on it without having to look at it tomorrow or in a few days' time. It needs to be more focused. And I think more and more with the autonomous world we're moving into, so everything's going to be smart cities, smart lights, smart cars, smart trains. That proactiveness and reactiveness needs to be front of mind.
Okay. Anything to add, Mike?
Yes, I would agree with that. I think what I've seen is that there's been this divergence into two types of big data environments. There's the historical, it used to be very much a batch-oriented thing, just replacing what was a data warehouse.
Yep.
And what we're seeing now is more of an operational big data environment where, I hate to say this, Patrick, where low latency products, no SQL databases such as your own and Mongo, they've started to emerge as being solutions that will sit alongside that more traditional data lake. So there's a dual strategy in a lot of organizations to approach that real time where decisions need to be made quickly to service us as customers.
Yeah.
I give you an example. I recently bought a new motorbike. I'm a very impatient person. I wanted insurance as quickly as possible for the best price for the least number of questions. And through technologies such as big data, they're able to bring all that data together about me, make a very quick decision whether to give me that product at an effective price. So there's a lot of benefit to these customers.
So
just on that, because a very big point now, I think, in today's world, you see it in retail more than in any other sector, but it will affect more banking, insurance, and others. A lot of what people are trying to do is customer retention, and I think when you have the likes of Amazon and disruptors going on in all sectors, you really have to look after your customers. And customer retention is a massive thing. People are losing customers every day, and being able to be a customer-driven or customer-first enterprise is more important than a product sometimes. And customer loyalty as well, and brand awareness, things like that are really important in today's world.
So I think you have to sort of revisit the reasons why people are building these things in the first place, because, okay, we know like the 3 Vs or the 4 Vs of big data, and there's a lot of focus and has been on the volume.
I like to call them the control Vs.
Right.
So the amount of time that people type big data into Google and then copy it and then go control V into a PowerPoint as they try to explain why we should invest in big data.
Right. But I think the one aspect why people are building these lakes is to be more agile, and of course streaming analytics is the kind of the nirvana to get to of that stage of being completely real time about how you do your analytics. But it's about being more agile, and by onboarding all this different data and providing easier access, you can answer those unknown questions where you don't know the structure of the data more readily, and providing the tooling to make that more available to your analysts, your data scientists, your business owners to actually participate in that. Otherwise, if you just structure everything and you gear things up towards answering the things that about the business of what's happened in the past, then you're just building a data warehouse. So we've seen cases where customers say they're building a data lake because they're using the latest and greatest Hadoop technologies or whatever it may be, but actually they're just redesigning the data warehouse in a data lake construct, which isn't really what this is about. It's about being more agile, and that has to sort of come from the business, really.
So we've met a lot of people so far that have been talking about, Gary mentioned before, about net new, and people getting quite panicked about, I've got to buy the latest and greatest. So what are you seeing in this space around big data strategy that people are still getting wrong? So we've talked a bit about the past, we've sort of got ourselves into the future, but I'm guessing there's still some commonality out there that people are still doing things badly or doing things wrong. What's your experience?
So the emerging thing that we've seen is the move to data ops, is where we have realized that it's no longer good enough that you develop a data pipeline. As I always say, you pull the pin out of the hand grenade and you throw it over the fence and it becomes somebody else's problem. Is the guys who develop the pipelines have developed them for a reason. They understand the business context in which they've been developed. They're the best placed people to manage and maintain them and to derive the business value out of it. And the whole idea of separation of duties is blurring as we move up the stack and the languages become more expressive and there's less low-level coding. What we're able to do is express the business value in code and execute and maintain and actually stop building pipelines that are reinventing the wheel every time, and actually move to a world where we're developing features, we create feature stores, and these feature stores are serving the features into machine learning. And actually, when people ask me, should I hire more data scientists or should I hire more data engineers, I always say you need to hire more data engineers. There's been in your average enterprise, there's been a fundamental lack of good disciplined engineering practice. And what we're starting to see as people recognize this, that actually there's 80% plus of the data that they have is feeding into 100% of their models. That actually there's nothing unique, that you have to redevelop every pipeline. And with an increase in regulation, where people want to understand model explainability, the evolution is we understand the model, now we want lineage, we want transparency in the data supply chain, and that only comes with good sound engineering practice. So you have the likes of Informatica for years that have been able to give you the full lineage, and lineage has always been an afterthought. Now it's becoming front and center because no longer is the human the last guardian of a decision. The software is making the decisions. So the software is eating software rather than software eating the world. And so in that world of the software relying on it, by the time the software's made a decision, there's no human to intervene.
Yep.
And so the only way in which you can actually promote these technologies is to give the business and risk committees the transparency in where the data's come from, what's happened to it, were we not only were we able to use that data to train a model, but was it the right thing to do? And so there has to be a lot more focus on data ops and data engineering. You
talk there about more ways of working. Interested to hear your guys' experience on, for me that still works, and has a big reliance on the tech, but also has a reliance on good quality data going in for good quality data coming out. So what's your experiences on that? Because I hear quality data or data quality or lack of still an awful lot.
Yeah, I think that's one that Louis would love to have, but I'll take it initially. And it's when we move into these new worlds of big data, well, it's not so new now, but there is this desire, this clamor to get onto the new tech, the new technology, new ways of working. But I think it's very important to remember best practice around data governance, mastering your data. Those things still apply, because you can bring in the best new AI tooling, the best new analytics tooling, but if you haven't got good control of that data, you're going to be analyzing rubbish and getting poor results out to your customers. So, whilst we want to move quickly, let's not forget all the good things we've done in the past that have got us to this point. Let's not avoid that best practice. Sometimes, you have to step back and actually go a bit more slowly. Just to think about what is that overall journey, and then you'd be better positioned to exploit it.
Well said. So, absolutely, data governance and privacy are huge considerations when you're building out a data lake, and I really like what you said about data engineers and data scientists working together. My view is that, and what we're seeing a lot of take-up of is catalogs, the data catalogs to help with things like the lineage, but also for different personas to come together and collaborate, so they can understand what the data quality is of different things in the lake, or things that they want to put into a lake environment, whether that's cloud storage or on-premise, wherever it may be. Understanding how the data engineers and data scientists can work together to optimize those flows. So governance is a really, really important part of what we do, of course, with how we're helping customers. But what we're seeing is that the best projects, the most successful ones, are the ones that think about governance. It can come at any point, but usually at the start, more successful. So, before I set out to build a lake, understand what I'm going to put in there, where it comes from, what type of transformations I need to apply to the data. So when I, construct my AI ML models, I know exactly what to go looking for from my catalog. That really gives me a source of truth, which is imperative, because I think, as you've alluded to, if you put garbage into an AI model, you're going to get garbage out, and there's a lot of prep work you need to do, which takes up 80% of the time for a data scientist, and they spend the other 20% complaining about that. So that's a really important thing you have to tackle.
I think that's a hard one. I think because if you look at the big data companies around us now, like the big Amazons, Facebooks, all that, they came from a place where they basically took all the data they could. But they were smart around their data. They looked at data and said, well, what parts can I use quickly, and what parts maybe in the future might be needed. But at regular cadence, they would throw away data and say, right, once data gets to a certain time, 3 months, 6 months, I don't need it anymore. But and a lot of it comes down to customer usage, customer journey. How are people using my product? How can I make it better for them? And the problem is, you don't know what you don't know at the time, right? So sometimes you do have to collect too much data. But I think to the data engineering point, you have to have a regular cadence of looking at your data. Does this still make sense? It's not just a one-off, I'm going to capture everything and I'm going to dump it here for the rest of the, for 5 years and try and make sense of it. It has to be a regular thing.
So just carrying on with that slightly, sticking with you, Patrick, one thing I'm intrigued about is how and whether companies are getting this right in terms of joining together their big data strategy, their tech strategy, and their organizational strategy. And you sort of alluded to it a bit there around we don't know what we don't know at the start. We might need the data in the future, but that might be driven by your organizational strategy. So do you think organizations are combining those three areas well, or is that still an area to learn?
Yeah, and I would think from a strategy point of view, I think nowadays everybody has to put their customer first. I mean, you could have a mediocre product, but if you have the best customer experience, the best brand awareness, you will win over a better product. And I believe that's where the best companies are doing their best work. You look at companies like Netflix and Spotify, Instagram, the companies that people now are building, and the growth of those companies, and Uber, they all put a customer experience before the tech.
Yep.
And when we think about tech, I think it's really important to remember that the only function of IT is to support the business. So if the IT function doesn't allow the business to grow and to be agile and to be flexible, then the IT isn't supporting them. It's not doing their job. And I think about how in the future when we look at data sets, as an architect, I have this problem, like where do we use our data? How do we use our data? The myriad of services now that we can take advantage of, whether it's cloud vendor or services themselves from vendors. But I want to be able to say, well, this data set, I want to be able to use Google's AI.
Yep.
But next month I might want to try it against Azure's AI.
Yep.
Or I might want to use AWS machine learning. And being flexible enough with my data and saying, well, I am not going to restrict my business or my data scientists or whoever. I want to be able for them to be able to choose and make decisions.
So Gary, what's your view in terms of, you've talked a lot about the data ops, and that for me feeds into sort of your operational strategy. What's your view on how well or not organizations are going at joining the big data strategy with other strategic initiatives?
So I don't think, I'm going to caught in controversy here, I don't think there's such a thing as a big data strategy. There is...
I'm amazed it's taken that long in the conversation to call that out.
There is a business strategy that's supported with technology. And I think of it, and I should have tweeted this about 2 years ago, is most organizations should be now thinking about how do I build a self-driving organization? So how do I apply machine learning, AI, to drive the business forward? And so a part of that component of change is improving the hygiene of how we manage, collect, and extract features that can then be exposed to actually build the self-driving car, and using that as an analogy. And a lot of time shouldn't be so much spent on what is the big data strategy, it should be what is the data collection strategy that enables us to drive the business forward. So if you are a, let's just say a asset manager, the thing that's going to drive your business forward is understanding the intent of a potential investor.
Yep.
And so what can you go and collect in things like ESG is a big thing in asset management, is people want to invest in funds which don't buy oil and gas, that don't invest in alcohol, that don't invest in arms. And all of a sudden you need to start thinking of how do I collect the data that enables me to execute on that strategy that a big percentage of my potential customers want ESG funds.
Yep.
And so if you don't have a data collection strategy in place, you can have the biggest big data strategy, AI strategy that you want. But if you're not collecting the raw material that can inform the business strategy, which is we're going 80% of our business in the next 5 years is going to be derived from ESG funds, then we need to go and start collecting that data that demonstrates to our customers that if you want an ESG fund, we're the guys to come to.
Yep.
So it's all about data collection strategies. We know big data technologies work, we know machine learning works. It's how can we make the business drive itself through these technologies.
So a nice segue into sort of the sort of next view, and coming to you, Martin. Grab your crystal ball and tell me what you think are the sort of trends coming up that we're not yet quite experiencing. You might be starting to see some use cases or some examples of where things are going next in the world of big data.
Well, in terms of the things that my customers are doing now to prepare them for the future, a lot of it's around microservices. It's being able to, having that vision of where they want to be in 12, 24 months' time, but every journey starts with a small step,
Yep.
and building microservices within their infrastructure so they can do things in a much more agile fashion in the future is one of the key things that I'm seeing. And also automation, the likes of containers and so forth, being able to quickly and automate new environments, new databases all the time to respond to the business strategy, but do it in a managed way that's governed and through process, but being ever more agile.
Okay. Louis?
So I'd say, coming back to the last point as well, I think we have to recognise the significance that companies are going through, digital transformation, and by onboarding more and more data, they have more opportunities. So we're working with a large vehicle manufacturer in the US, for instance, who are collecting so much telematics data about localized weather, and data from the rain, windscreen wipers, and everything else. They've actually got more weather data than the Weather Channel. And that opens up new business opportunities. So sometimes it's not obvious from a digital transformation strategy which way you're going, but data can empower these things.
Yep.
And I think that's quite significant. Another example is I think all have views on the importance of AI and machine learning, and that's very, very topical right now. But the applications of that go beyond just applying it to the data. So I spoke a little bit more before about cataloging, and that can help understand where data is flowing within the organization.
Yep.
But if you really understand the data, how it's flowing, what it's used for, then it really allows you to build things like self-integrating systems and make predictions on where data should arrive, so it's arriving in a timely fashion for the applications that need it, and really enable these digital transformation programs. So I see AI and ML just being used throughout this whole journey.
So it's an interesting point, and I'm interested to hear from the guys around, you hear AI, ML, big data, almost in the same breath. So what experience are you seeing, or what view do you have on how better big data can support AI, and how AI can help manage big data? Patrick?
Well, they go kind of hand in hand. Everything is about the data when it comes down to it. We talked about the garbage in, garbage out, but you can't make a self-driving car without collecting massive amounts of data, and that's over time in terms of machine learning, understanding what the car should do in certain situations, but then in real time. So if it sees something in the road, if it sees accidents, if cars are moving around it. So there's, it's kind of data overload. If you think about how much data is processed for a car journey, and then you think, well, every car, if you're a car maker, you need to know about that journey, what happened, all the data points that actually happen to understand how your cars are performing. So I think IoT in particular is going to be, it's a trend now at the moment, but I believe that is the thing that's going to kind of take over the data size in our universe.
Yep.
And the other point I was going to make just on the last bit was, I think what we've done very well in the last 5-10 years is make applications portable, and make AI and these things portable, to be able to use them wherever, using things like containers and VMs. But we haven't been able to really make our data portable. And I think until we can unleash data, or have what I call fluid data, and it doesn't have to be huge amounts, but data has to be able to move to where you want it to be, where you need it to be successful, right? For the business to be able to take advantage of that. So I think they're the two things that I think, IoT and that data, freedom of data, I think is the big things for me.
So one trend that we're hearing in the news in terms of data and big data has been bias. So without naming any names, this sort of bias, yeah. So we talk about AI, we talk about algorithms, and the data that is used, and the bias that can creep in. Listening to some talks recently of women, for example, talking about gender bias and how that is arguably nobody's fault. It's the way we're all programmed, excuse the pun. I'm interested to know what your view is on how that can be tackled, as far as, I think data is growing. Big data is now, for me, I feel like a real thing, whereas a few years ago is the next bingo word. How can we build and tackle that problem in terms of the trends that might be coming through? Gary?
So when we look at this whole concept of bias, I think it goes back to my earlier statement, is a lack of a well thought out comprehensive data collection strategy. So if you are only collecting data about salaries of males, then there's a good chance when you build a model and you're trying to figure out credit limits for females that you might get it wrong. And so a lot of time and effort needs to be injected into the data collection strategy. It's to understand the data before you even choose what machine learning architecture that you're thinking about implementing. Is have you collected data in a way that is both representative of what you're trying to choose, and also being very directed for the intended purpose. So if you are thinking of building a machine learning model to predict what product you might want to buy, you need to start with who your customer is and how should we be collecting that data, and then this whole concept of sort of rigorous testing, back testing, and understanding whether the model is delivering the results you want.
Great.
And then sometimes, just because you can, doesn't mean you should. And I think this is one of the things that we don't spend enough time thinking about, is the ethics of AI. I commonly joke, those that can machine learn, those that can't talk about ethics. And where we're now at is, it's no longer a joke. It's the ethical side is starting to come. I recently ran an event where we talked about AI and ethics, and is ethics in AI a human right? Which is interesting. Is there a legal angle that you need to apply to it? And the other one is even thinking about simple things like de-identification of data. You de-identify the data, the machine learning is half as effective. But if you are living in this world of, we've de-identified the data, I can't trace it back to who it actually is, then you're mistaken, because there is loads of methods to re-identify the data. So it is understanding that you have a framework in place that actually can understand whether it's something you should be doing. I think we're moving towards a business model, and we've seen it recently in the news, where a lot of CEOs in America have signed up to this sort of, it's not profit at any cost. It is actually a holistic business model where we do have to start thinking about these ethical questions, and that it's not shareholder value first, customers second, employees third. It is, sometimes you might have to sacrifice some immediate gain for a more ethical standpoint, and maybe your customers will appreciate that you actually have an opinion.
So Louis, I think Gary there talks about the data collection sort of strategy in terms of dealing with that bias. Where do you think solid data governance fits within that? And in your view, is that the most important thing in terms of dealing with some of this bias in big data?
Yeah, I think obviously it's not the machine learning algorithms and data science routines that are biased, it's the humans building those models and all of the interactions around that, and maybe some of the things that have come out recently expose that. So that's no bad thing in a sense. It's exposing the reality. But I think that, of course, it's important to have a good governance program, data quality program, so you can actually clean the data before you pass it into such algorithms, applying things like, automation around one-hot encoding, removing the bias where you can before you plug into machine learning algorithms. That's important. You mentioned depersonalization of the data, but then also running that against production data.
And I think
being able to operationalize that is
another critical thing to build into the framework is this concept of an ethical override. And we don't talk about ethical overrides enough, is if the data and you perceive it is to be biased, that within the pipeline that actually makes a decision, that you can either dial up or dial back the ethical overrides. So for example, you train a machine to make claims payments, and a child is not covered under the policy. But as a human, ethically, you'd go, actually we'll pay out if a child dies of leukemia on their parents' critical illness policy, because that's the right thing to do. So within the machine learning model, you have an ethical override that says, even though we've never paid a claim, it's the ethical thing to do. And I think you'll start to see increasingly amount of people paying attention to how can we dial these ethical overrides into our machine learning models.
So how do you how do you build that type of scenario where you have a human override into your data governance plan? Because that's something you want to try and capture. You'd want to know that somebody's done that, and how do you know that that individual has the rights to dial up or dial down? Martin?
I think that's part of the feedback loop you have in your business. You think about, why are we doing all of this in the first place? My belief is that we're trying to get good data to enable us to make good business decisions very quickly. Now, and you have to monitor the impact of those business decisions. And if you find that those business decisions are not what you anticipate, you're not meeting your ethical objectives, then there is a feedback loop, and you have to examine, right, where in that process of the data collaboration, the data collection, processing, decision making, or the AI, did we go wrong, or what do we need to adjust slightly in order to get back to where we need to be as a business?
Cool.
I think it's an important thing with the whole ethics conversation as well. It's and bias. It is important to remember that data is really powerful, right? And when we talk about learning about customers and how they do things and all that kind of stuff, it feeds back into things like coercing or manipulating or talking to certain demographics, so it can be used in the right way, and it can certainly be used in the wrong way. And we've seen across two large nations what it can do to maybe people who are easily convinced,
yep.
or certainly take social media more at its word than it should be.
Yeah. Okay. So just sort of to wrap up the conversation, if people were watching this and it's the first time at Big Data London and they're about to start on their big data journey, first of all, where have they been for the last 5 years? Secondly, more importantly, what would be your one giveaway to them? Say, well, go away, and where would they start? So what's the one thing I can go away and do tomorrow? Martin?
Think about where is it you want to be, ultimately, and then decide on what is that first next step that takes you on that journey.
Cool.
Yeah, very similar. Think about solving problems in the now. Think about the real-time feedback loop into whatever it is you're doing. Whatever industry it is, whether it's automotive, finance, insurance, it's all about the now. Trying to keep people engaged,
yep.
and provide relevant information.
Good. Gary?
I'm dead boring. I get asked this question quite often, and I always go back to learn SQL. If you get a fundamental understanding of the language, the constructs, and how you query things, it is the foundation. Before you learn all the other esoteric technologies, if you have a fundamental understanding of SQL, you can't go wrong, and then that just builds on and builds on and builds on. And also, it's around being creative. Is if you can have both the SQL on the one hand and understand business problems and be very creative,
yep.
and mesh the two together, because we will start to see the rise, because of the technology, of the more technical oriented business person who is as good as SQL and Python as our average business person is today in Excel.
Yep.
So we're starting to slowly but surely, people are coming out of university who have no idea what Excel is, but they have a fundamental understanding of SQL and Python. And we're going to see a huge amount of business change because Excel starts to take a backseat.
Great. Louis?
So I think generic advice is start small, think big, but scale very fast. And there's a lot to be said for that in terms of what we've seen in successful projects and how they go. But I would say understanding your data is really key. So if you're trying to build a lake, build a new data initiative around the data that you have, you need to understand it very well, what you have, where it resides, the quality of it. A catalog is key for that and could be the start of any journey, whether it's for an analytics project, for a data governance project, for mastering your data, whatever it may be. Cataloging is a great place to start with that.
Cool. So thank you everyone. Thank you Martin, Patrick, Gary and Louis. I'm off to go and learn some SQL. Thank you everybody for watching, and I hope you enjoy the rest of Big Data London.